నేను అన్నీ ఆన్ చేసి బతికి కరెక్ట్ వస్తాను. హలో చెక్
Okay, sir. Good morning, children. Welcome back to Nandi online classes. In the last class, we discussed CET problems under differentiation chapter. Let us continue some more problems. Okay, write down problem number 42. If y is equal to root of tan x plus root of tan x plus root of tan x and so on infinity, then dy by dx is equal to, then dy by dx is equal to, okay, solution. If y is equal to root of tan x plus root of tan x plus root of tan x and so on infinity, then dy by dx is equal to, what is its answer? Here y is given, we are going to differentiate this function. It is in the form y is equal to root of f of x plus root of f of x plus root of f of x plus and so on infinity. Then dy by dx formula, dy by dx. Yesterday we given the formula. What is formula? F dash x divided by 2y minus 1. F dash x by 2y minus 1. So we can use PUC method. Yesterday last problem we did two methods. So I am using shortcut method now. So what is formula is dy by dx is equal to f dash x by 2y minus 1. Here f of x, what is f of x? Here f of x is tan x. So side f of x is equal to tan x. Okay, differentiate f of x derivative f dash x. d by dx of tan x is secant square x. d by dx of tan x is secant square x. Substitute it. F dash x is secant square x divided by 2y minus 1. So that is dy by dx. Suppose if you forgotten formula, you can use the method y is equal to root of tan x plus remaining all denoted by y. Y means root of tan x plus root of tan x plus root of tan x. Squaring on both sides, take y terms one side, differentiate, you will get my answer only. Okay, write it. Okay, next problem. Problem number 43. If y is equal to root of x plus root of x plus root of x plus and so on infinity, then dy by dx is equal to, then dy by dx equal to, okay, solution. Here y is given, we are going to differentiate y. It is in the form y is equal to root of f of x plus root of f of x plus root of f of x and so on infinity. So what is formula is f dash x by 2y minus 1. So dy by dx is equal to f dash x divided by 2y minus 1. Here f of x, what is the function is f of x is x, differentiate f of x derivative f dash x, x derivative 1, substitute here is equal to 1 by 2y minus 1. So answer is 1 by 2y minus 1. Okay, write it. This is given in the CET examination, previous CET examination. Okay, next problem number 44. If y is equal to x power and so on infinity, if y is equal to x power x and so on infinity, then x into 1 minus y log x into dy by dx is equal to, if y is equal to x power and so on infinity, then x into 1 minus y log x into dy by dx is equal to, what is derivative of this function? Okay, solution. Okay, first I will do the two methods, one PUC method, one CET method. If you forgotten formula how to do, if you have formula how to do. Okay, write the given function. Y is equal to x power and so on infinity. I want dy by dx. So y is equal to x power and so on. How many x's may be? It can be treated as y. This is all replaced by y. Given function only. Y is equal to x power. This is all replaced by y. Okay. Take log on both sides. Log y is equal to log of x power y. Okay, log y is equal to, it is in the form log m power n. Log m power n is n log m. So y log x. Okay, differentiate with respect to x. Log y derivative is 1 by y. Into y derivative is dy by dx. Log y is 1 by y into y is dy by dx is equal to, this is UV rule. First function same, log x is 1 by x plus second function log x same, y derivative is dy by dx. First function same, log x is 1 by x plus log x same, y is dy by dx. Take dy by dx terms one side. 1 by y into dy by dx. Log x into dy by dx send that side, minus log x into dy by dx is equal to y by x. Okay. What you can take common? Dy by dx. Take dy by dx common. First term 1 by y minus log x is equal to y by x. Dy by dx into, in the bracket take LCM. LCM is y. Numerator 1 minus y into log x, y log x is equal to y by x. Okay. Then cross multiply dy by dx into x into 1 minus y log x is equal to y into y is y square. Cross multiply y into y is y square. This is x into, write in order, x into 1 minus y log x into dy by dx is equal to y square. So they asked x into 1 minus y log x into dy by dx. Answer is y square. So what is the answer is y square. Okay, write it. Y is equal to x power and so on infinity. Y is equal to x power and so on. How many x's may be? That is replaced by y. So take log on both sides, differentiate, you will get the answer. Okay, I am doing shortcut method, right? Second method. Second method. Suppose you by hearted the formula, how to do? Right, it is in the form, if y is equal to f of x whole power f of x and so on infinity. If y is equal to f of x whole power f of x and so on infinity, then dy by dx formula, then dy by dx is equal to y square by 1 minus y log of f of x into f dash x by f of x. I given in the synopsis also. This formula I given in synopsis. If y is equal to f of x whole power f of x and so on infinity, then dy by dx formula y square by 1 minus y log f of x into f dash x by f of x. Substitute this one. According into problem, what is f of x? If you compare to given function, what is f of x? F of x is x. So here f of x is equal to x. Differentiate f of x derivative f dash x derivative is 1. Substitute it. Y square by 1 minus y log f of x is x. Y square by 1 minus y log f of x is x into f dash x is 1. F of x is x. LHS side dy by dx is there. Cross multiply x into 1 minus y log x into dy by dx. So x into 1 minus y log x into dy by dx is equal to y square 1 ja y square. So that is the answer. If you have formula, direct answer will come y square. So write it. This is shortcut method. If you by hearted the formula, if you by heart, time will be reduced. Here f of x is x, f dash x 1 by f of x is x. Right. Problem number 45. If y is equal to sin x whole power sin x and so on infinity, then dy by dx is equal to, then dy by dx is equal to, okay, solution. Okay, if y is equal to sin x whole power sin x whole power sin x and so on infinity, then what is the derivative of this function? So I am writing the formula. See, dy by dx is equal to, formula is y square by 1 minus y into log of f of x into f dash x divided by f of x, that is formula. Okay, what is f of x? If you compare the function, it is in the form y is equal to f of x whole power f of x whole power f of x and so on infinity. So f of x is sin x. Here f of x is equal to sin x. Okay, differentiate f of x derivative f dash x, sin x derivative is cos x. Substitute is equal to y square by 1 minus y into log of f of x is sin x into f dash x means cos x, f of x means sin x, right, is equal to y square by 1 minus log of sin x whole power y, n into log m can be written as log m power n, into cos x by sin x is cot x. So is equal to y square into cot x divided by 1 minus log of sin x whole power y, sin x whole power y can be written as given function y, sin x whole power given function is y, so y. So that is the options answer. Y square into cot x by 1 minus log of sin x whole power y, sin x whole power y is given function y. So that is dy by dx. Right, note it. Here sin x whole power y, sin x this is y, sin x whole power y is y. Next problem 46. Right, if y is equal to x square plus 1 by x square plus 1 by x square plus and so on infinity, then dy by dx is equal to, then dy by dx is equal to, okay, solution, model change, right, understand. If y is equal to x square plus 1 by x square plus 1 by x square and so on infinity, then dy by dx is equal to, here one function is given, what is the derivative of this function? Okay, write the given function, right, y is equal to x square plus 1 by x square plus 1 by x square and so on infinity. Okay, I will do two methods. If you forgot formula, how to do? If you have formula, how to do? So if you forgot formula is, right, y is equal to x square plus 1 by, see that this is all replaced by given function y. What is y? X square plus 1 by x square plus 1 by, like that, x square plus 1 by x square plus and so on is there. So replaced by y. Take y terms one side, y minus 1 by y is equal to x square. Differentiate with respect to x. Y derivative is dy by dx minus, it is in the form d by dx of 1 by x. What is d by dx of 1 by x? minus 1 by x square. D by dx of 1 by x is minus 1 by x square. So minus 1 by y square into y derivative is dy by dx. It is in the form 1 by x. D by dx of 1 by x is minus 1 by x square into x derivative 1 need not to say, but y is dy by dx. X square derivative is 2x. From two terms take dy by dx common. Dy by dx common. First term 1, minus into minus is plus, y square is equal to 2x. Right, dy by dx is equal to 2x by 1 plus y square. Oh, sorry, 1 by y square. Here 1 by y square is there. Okay, take dy by dx common. So dy by dx into, take LCM, LCM is y square, numerator y square 1 ja, y square plus 1 is equal to 2x. Right, dy by dx is equal to cross multiply, 2x into y square is y square 2x by 1 plus y square. Okay, that is dy by dx, derivative of the given function. Okay. Second method I am doing. Right. Second method is if y is equal to f of x plus 1 by f of x plus 1 by f of x and so on infinity, then dy by dx formula, then dy by dx I given in the synopsis also. If y is equal to f of x plus 1 by f of x plus 1 by f of x and so on, formula is y square by 1 plus y square into f dash x, y square by 1 plus y square into f dash x. If you observe the given function, what is f of x? F of x is y is equal to f of x plus 1 by f of x. So f of x is x square, side right. Here f of x is equal to x square, differentiate, f dash x is equal to x square, derivative is 2x, substitute, is equal to y square by 1 plus y square into f dash x is 2x, is equal to 2x y square by 1 plus y square. Okay, that is the answer. See that same answer, 2x into y square by 1 plus y square. Both answers are same. If you have formula, you can save the time as early as possible. So dy by dx is very easy for you if you by heart the formula. Okay, next problem. Okay, problem number 47. If x is equal to e power y plus e power y plus and so on infinity, then dy by dx is equal to solution. Right, different models we are covering. Right. If x is equal to e power y plus e power y plus e power y and so on infinity, like that, how many e power y's may be and so on infinity, then dy by dx equal to, what is the differentiation of this function? Okay, write down the given condition. X is equal to e power y plus e power y plus and so on infinity. How to do? X is equal to e power y plus this is all replaced by given function x. E power y plus e power y plus and so on, nothing but what? Given function only. What is x? E power y plus and so on. So this is all replaced by x. Power is there, take log on both sides. Log x is equal to log of e power y plus x. Right, log x is equal to, it is in the form log m power n. Log m power n is n log m. So y plus x into log e. Y plus x into log e. Right, log x is equal to y plus x into log e value. What is log e? 1. So log x is equal to y plus x, 1 ja y plus x. Differentiate with respect to x. D by dx of log x is 1 by x. Y is dy by dx. X is 1. I want dy by dx. So 1 by x plus 1 become minus 1 is equal to dy by dx. Take LCM. LCM is x. Numerator 1 no minus x, 1 ja x. LCM x, numerator 1 minus x, 1 ja x is equal to dy by dx. Reverse. Therefore dy by dx is equal to 1 minus x by x. Okay, that is the derivative of the given function. Okay, write it. X is equal to e power y. This is all replaced by x. To differentiate, take log on both sides. After that, differentiate. Okay, no shortcut method for this one. No shortcut method is there, but it is very difficult formula, so you cannot by heart, so leave it. So move to another method. We will do problems under mean value theorems, Rolle's theorem and mean value theorem. First I will do Rolle's theorem. What is statement? Rolle's theorem statement. What is Rolle's theorem statement? F of x is continuous on closed interval a comma b. F of x is differentiable on open interval a comma b. See, f of x is continuous on closed interval a comma b. Second, f of x is differentiable on open interval a comma b. 3. If f of a is equal to f of b, if f of a is equal to f of b, then there exists a real number c in open interval a comma b such that f dash of c is equal to 0. F dash of c equal to 0. First one continuous, second differentiable, third f of a is equal to f of b. If 3 conditions are satisfied, then there exists a real number in the given interval that is such that f dash of c equal to 0. At that point derivative is 0. F dash of c equal to 0. So to get the value of C, which formula we use in Rolle's theorem? F dash of C equal to 0. So do the problems under that method. Okay, write down the problem. Right, next problem number 48. The value of C, in the Rolle's theorem, for the function f of x is equal to x cubed minus 3x in the interval closed 0 comma root 3 is closed interval 0 comma root 3 is right. Understand the question. The value of C in the Rolle's theorem for the function f of x is equal to x cubed minus 3x in the interval closed 0 comma root 3 is, here f of x given, interval given. What is the value of C in Rolle's theorem? To get the value of C in Rolle's theorem, which formula we can use? F dash of C equal to 0, differentiate, equate to 0. Okay, write the given function. So f of x is equal to x cubed minus 3x, differentiate f of x derivative f dash x cubed derivative 3x square minus 3x derivative is 3. Now to get the value of C, equate to 0, f dash of C is equal to 0. F dash x we know 3x square minus 3. Put C, put x value C. So 3c square minus 3 is equal to 0. 3c square minus 3. Right. 3c square is equal to 3. C square is equal to 3 by 3, 1. C is equal to square become plus or minus root 1 is 1. So we got two values for C. Which C belongs to interval? Therefore C is equal to 1 belongs to open interval 0 comma root 3. Root 3, what is root 3 value? 1.732. 1.732. So 1 belongs to that interval, but minus 1 does not belongs to given interval. Here C not equal to minus 1. So what is the value of C is 1. So in the options 1 is there, minus 1 also there, but minus 1 does not belongs to this interval. Okay, write it. Right. Problem number 49. The value of C, in Rolle's theorem, for the function f of x is equal to e power x into sin x, comma x belongs to closed interval 0 comma pi is, closed interval 0 comma pi is. Right, solution. Here f of x given, f of x is equal to e power x into sin x. Interval given, closed interval 0 comma pi. What is the value of C in Rolle's theorem? To get the value of C, which formula we can use in Rolle's theorem? F dash of C equal to 0. So differentiate, put x value C. Okay, write the given function. F of x is equal to e power x into sin x. Differentiate f of x derivative f dash x. Two terms are there, apply UV rule. U v dash plus v u dash. First function same, e power x same. Sin x derivative is cos x plus second function same, sin x same. E power x is e power x. E power x into sin x is cos x plus sin x into e power x derivative e power x. What you can take common? E power x. Take common, you will get cos x plus sin x. To get the value of C, use the formula f dash of C equal to 0. Now, f dash of C is equal to 0. This is f dash x, put x value C, e power C into sin cos C plus sin C is equal to 0. From this I am going to find C value. Right, cos C plus sin C is equal to 0 by anything is 0 by e power C, 0 by anything is 0. Right, sin C is equal to plus cos C become minus cos C. Okay, sin C divided by cos C is equal to minus 1. Plus cos C become minus cos C. Sin C by cos C is equal to minus 1. If you cross multiply, last equation comes. Sin by cos C is tan. So tan C is equal to minus 1. Minus 1 in terms of tan. Minus 1 in terms of tan. Tan is negative in which quadrants? Positive. Positive in which quadrants? First to third. Negative in second and fourth. So second quadrant I will take. Why? 0 to pi is there. 0 to pi. So second quadrant. Second quadrant means 180 minus theta. So like that. So tan C is equal to minus 1 can be written as tan pi by 4, tan 45, 1. Tan C is equal to minus tan theta can be written as tan of 180 minus theta, pi minus pi by 4. See ma, tan 180 minus theta, formula is minus tan theta. Tan 180 minus theta is minus tan theta. That's why minus tan theta can be written as tan 180 minus theta. Second quadrant, tan is negative, 180 is there, tan become tan. Right, remove tan. C is equal to 4 into pi, 4 pi, 4 pi minus pi, 3 pi by 4. Okay, that is the value of C. C equal to 4 into pi, 4 pi minus pi, 3 pi by 4. 3 pi by 4 means how many degrees, sir? 3 into 45, 135. 135 belongs to this interval. Belongs to open interval 0, pi. Tan 135 is minus 1. Okay, right, another problem number 50. The value of C, in mean value theorem, for the function f of x is equal to x into x minus 2 and x belongs to closed interval 1, 2 is closed interval 1 comma 2 is right. Solution. Understand the question. The value of C in mean value theorem. First of all, let us discuss the statement of mean value theorem. Statement of mean value theorem, MVT. What is statement, ma? F of x is continuous on closed interval a comma b. F of x is differentiable on open interval a comma b. If these two conditions are satisfied, there exists a real number C in open interval a comma b such that f dash of C is equal to f of b minus f of a divided by b minus a. Continuity, differentiability has to satisfy. After that, there exists a real number C in that interval. At that point, differentiation is equal to f of b minus f of a by b minus a. This is the formula to get value of C in mean value theorem. Mean value theorem is also called Lagrange's mean value theorem. Name of the scientist, Lagrange's. That is, previous is what? Rolle's theorem. Name of the scientist, Rolle's. Here Lagrange's. Okay. F of x given, interval given, they said mean value theorem. What is the value of C? Write down the given function. F of x is equal to x into x minus 2. F of x is equal to x into x is x square minus 2x. Differentiate. F of x derivative f dash x square derivative 2x derivative 2. Now write the formula for C. Now f dash of C is equal to f of b minus f of a divided by b minus a. Right. F dash of C is equal to what is a b? Given interval is a comma b. Given interval is, it is in the form x belongs to closed interval a comma b. So f of b means f of 2. F of a means f of 1 by b minus a 2 minus 1. Okay, is equal to f of 2. F of 2, substitute in the given function. F of 2 square 4. 4 minus 2 2s are 4. 4 minus 4. 4 minus 4. F of 1 square 1 minus 2 1s are 2. By 2 minus 1 is 1. Right, is equal to 4 minus 4 is 0, minus of minus 1 by 1 is equal to 1 by 1 is 1. 4 minus 4 0, 1 minus 2 minus 1, minus into minus plus 1. LHS said f dash C, f dash of C is 2C minus 2, put x value C, 2C minus 2. 2C is equal to 1 plus 2, 3. C is equal to 3 by 2. Belongs to open interval a comma b 1 comma 2. Each it belongs to 3 by 2. 3 by 2 means 1.5. 1.5 belongs to 1 comma 2. So that is the answer. Okay, so you need not to confuse Rolle's theorem or mean value theorem or different formulas for to get value of C. Another shortcut method I will say, see, if the given function is a quadratic expression, if the given function is quadratic expression, then what is the value of C is? C formula is a plus b by 2. If the given function is only quadratic, what is the value for C is a plus b by 2. A 1, b 2. So is equal to 1 plus 2 by 2 is equal to 3 by 2. See that 3 by 2. This is shortcut method. If the given function is only quadratic, cubic like different is there, no formula. This is only quadratic. This is the formula for C. C is equal to a plus b by 2. So 1 plus 2 by 2 is equal to 3 by 2. Right. You do one problem as homework. 51. Right. F of x given, f of x is equal to x plus 1 by x. X belongs to closed interval 1 comma 3. You do this problem as homework. Okay, thank you. We will meet in the next class.
You are correct. No risk. Good morning, children. Today I will continue the remaining part in complex compounds. Yesterday we discussed one very important concept, that is CFT, crystal field theory. Here two complexes, one is octahedral complex, another one is tetrahedral. I will discuss one more time. In octahedral complex, 6 ligands approaches along the axis. Due to this reason, the more the repulsions are developed between easy set and 6 ligands. Why? Because easy set are 2 orbitals, dx square, y square and dz square, in these lobes along the axis. So due to this reason, all the lobes along the axis causes more repulsions, hence the energy of easy is increases, T2G decreases. So finally in octahedral complex, energy of easy greater than energy of T2G. This is one. Another one is in tetrahedral, but in tetrahedral 4 ligands approaches between the axis. So in T2G 4 lobes between the axis. Due to this, more the repulsions developed between orbitals of T2G and ligands. Okay, children? Then due to this reason, the energy of T2G increases but energy of EG decreases. It is in tetrahedral complex. Now one more concept is pairing energy. Okay, children, I will continue. The next part is pairing energy in octahedral and tetrahedral complex. See, before once again we will discuss octahedral complex. Octahedral complex. What happening in octahedral, children? Just 5 degenerate orbitals in the metal atom or ion. Next, this is average energy in the spherical field. Next, when 6 ligands approaches along the axis, here it's split into 2 sets. One set is EG set, another set is T2G. EG set, you know very well children, 2 orbitals dx square minus y square and 2 z square. Okay children, more repulsions between the electrons of EG and electrons of ligand, hence energy of EG set increases. This is increasing energy, so energy increases. T2G, again 3 orbitals children, dxy, dyz, dzx. Okay children, this is Barry center. Yesterday we discussed now. This energy is increasing energy. It is plus 0.6. It is decreasing energy minus 0.4. This is delta O. O is CFSE of octahedral complex. Now come to the point. Today's topic is pairing. Suppose, see, what is the conclusion in octahedral complex children? Energy of T2G is less than that of energy of EG. The energy of T2G orbitals is less than that of energy of EG set. You know very well. Why? Because already given one hint. More repulsions increasing in energy, less repulsions decreasing in energy. Now come to the point. What about electrons? Generally electrons enters into first T2G or EG. According to above principle, you know very well, first electrons enters into lower energy level, then higher energy level. Suppose one electron is enters into, first electron enters into T2G. First electron, how many orbitals in T2G children? dxy, dyz, dzx. This is from this diagram. First electron T2G orbital, second electron T2G orbital, third electron T2G orbital. What about fourth electron? Here two probabilities. Either fourth electron enters into either T2G or EG. Again repeat children, first electron T2G. Why? Because less energy. Second electron also T2G. Third electron also T2G orbital. What about D4? Suppose the complex has a D4 configuration, D4 ion. What happening? If D4 means two probabilities, the fourth electron enters into T2G orbital or EG orbital. Note down children, in octahedral complex, first, second, third, first 3 electrons T2G. Okay children, no doubt at all. Why? Because energy of T2G is less than that of EG. What about fourth electron? No doubt, this point is very important. If D4 ion or D4 configuration, then the fourth electron enters into either T2G or EG. This is depends on delta O and P. No doubt. Note down children, the fourth electron, two probabilities, enters into either T2G, fourth electron, if it is D4 complex, D4 ion in the complex, fourth electron enters into either T2G or EG. If it is T2G, what is the configuration children? T2G 4, EG 0. If the electron enters into T2G or EG, T2G 3, EG 1. Two probabilities. What are the point children? Fourth electron enters into either T2G or EG set. Suppose if the fourth electron enters into T2G, this is pairing will start. So T2G 4, EG 0. This is probability 1. Another probability, if fourth electron enters into EG orbital, so T2G 3, EG 1. So this is first probability, this is second probability. This is depends on, note down, this entering of electrons into orbitals depends on delta O and P. This is crystal field splitting energy in octahedral complex P. Now come to the point, what is P? Note down here, P is called as pairing energy. Sir, what is pairing energy? The energy is required to pairing the electron in a single orbital is called as pairing energy. Note down, children. Fourth electron enters into either T2z or EZ. First probability, if it is enters into fourth orbital T2z, T2z 4, EZ 0. This is one probability. If fourth electron enters into EZ, so T2z 3, as usual EZ 1. So this entering or this type of concept is related to or depends on delta O and P. What is P? Pairing energy. What is pairing energy? Note down, children. The energy required for pairing of electron in single orbital. This is very important concept. What is P, children? This pairing depends on delta O and P. What is P? Pairing energy. Define pairing energy. The energy required for pairing of electron in single orbital. Here two cases, children. Case 1, if delta O is less than P, the fourth electron enters into EZ set, children. Therefore, T2z 3, EZ 1. Second probability, if delta O greater than P, the fourth electron, fourth E minus, nothing but electron, enters into T2z and paired. See, finally it is T2z 4. So therefore, it is T2z 4, EZ 0. So that's why finally the pairing is depends on the delta O and P relation. What is the relation 1? Probability or if delta O less than P, the fourth electron enters into EZ set. So therefore it is T2z 3, EZ 1 arrangement. Another case or second case, if delta O greater than pairing energy, the fourth electron enters into T2z. So therefore it is T2z 4, EZ 0. Next, in this case the ligand is weak field ligand. No doubt it is the presence of weak field ligand, and this complex is called as, already explained in VBT, high spin complex. High spin complex. What about second case? If delta O is greater than P, pairing energy, in this case in presence of strong field ligand, and this is called as low spin complex, children. This is very important cases. Don't worry, don't confuse only two cases. Delta O is less than P, no pairing. So fourth electron enters into EZ. So T2z 3 as usual, fourth electron into EZ. Okay, this is in presence of weak field ligand and it gives high spin complex. If delta O is greater than pairing energy, so pairing start or pairing takes place in the T2z. So fourth electron enters into T2z. So finally T2z 3 plus 1, fourth electron, it becomes T2z 4, EZ 0. Okay, in this case in presence of strong field ligand and it is low spin complex. The first one is weak field ligand, high spin complex. Second case, strong field ligand and low spin complex. This is the relation between crystal field splitting energy and P. What is P, children? Pairing energy. The energy required for the pairing of electron in single orbital. Okay, children? This is one of the important concept. Simple concept. This concept explains the pairing of electrons in various orbitals like T2Z and EZ. Our electrons are enters into various orbitals, depends on the delta O and P. P is pairing energy. Next, factors influence the magnitude of CFS energy. This is delta O or CFS, crystal field splitting. Note down, children, factors influence the magnitude of CFS. What is CFS? Crystal field splitting. Here there are three factors, children. First one is the splitting of orbital depends on nature of the ligands. Second, charge on the central metal. Third, position of central metal in periodic table. Note down. What is the next topic, children? Small topic. Very simple. Factors influence the magnitude of CFS. What is CFS, children? Crystal field splitting. Or this is nothing but delta O. Okay, symbol is delta O. This splitting depends on three factors. One is nature of the ligands in the compound or complex, charge on the central metal, and position of the central metal or metal in the periodic table. Generally, weak field ligands causes small splitting, whereas strong field ligands causes more splitting. So the splitting depends on the nature. Here too, one factor, weak field ligands causes small splitting, whereas strong field ligands causes large splitting. So finally the splitting or the extent of splitting depends on the nature of the ligands. Okay, weak field ligands causes small splitting, strong field ligands causes large splitting. This is one of the factor. Charge on the central metal. If positive charge increases on the central metal, the extent of splitting or the magnitude of splitting also increases. Note down, charge on the CM. Note down, if the charge or positive charge, you know very well, positive charge only present on the central metal. If the positive charge increases on the central metal, magnitude of CFS also increases. Note down, children. First factor is nature of the ligand. Second factor, charge. What is the relation between charge and magnitude? If the positive charge increases on the central metal, the magnitude of splitting or crystal field splitting also increases. Third, position of the central metal in the periodic table. Generally down the group, CFS increases. Down the group, CFS increases. For example, see 3D, 4D, 5D. What is the order of extent of splitting? 3D less than 4D less than 5D. or 5D greater than 4D greater than 3D. So note down children, position. Suppose 3 complexes given children. In complex 1, central metal goes to 3D series, next 4D series, next 5D. 3 different complexes, 3 different central metals, 3 different series. What is the extent of splitting? Down the group, crystal field splitting increases. This is the trend. So write either first one or second. The extent of magnitude of splitting 3D less than 4D, 4D less than 5D, or 5D greater than 4D greater than 3D. These are the factors influence the magnitude of crystal field splitting. One is depends on the nature of the ligand. Second one is charge on the central metal or ion. Third one, position of the metal in the periodic table. Generally, weak field ligands causes small splitting, whereas presence of strong field ligands causes a large or more splitting. If the positive charge increases on the central metal, magnitude of splitting also increases. Down the group 3D, 4D, 5D, the extent or magnitude of splitting also increases. The order is 3D less than 4D, 4D less than 5D, or 5D greater than 4D greater than 3D. These are the factors influence the magnitude of CFS. What is CFS children? Crystal field splitting. Okay children. Next. And one more small point, limitations. Limitations nothing but drawbacks. What are the limitations in crystal field theory? I will give few important points. Limitations nothing but drawbacks. We will discuss few limitations. No doubt. Limitations of CFT. Limitations of crystal field theory. Here two limitations children. The first point is this theory cannot explain the covalent bonding nature between central metal and ligand. See, central metal is etc. This is ligand. Between this covalent bond is there. So, but this theory cannot explain the covalent bond between central metal ion and ligand. This is one of the drawback or demerit. Drawback, demerit or limitation. Drawback. First point, this theory cannot explain the covalent bonding between central metal and ligand. And one more very important second point, limitation, spectrochemical series. Yesterday we discussed the increasing order of field strength of different ligands in spectrochemical series. Series nothing but order. What is spectrochemical series children? The order of the arrangement of increasing order of field strength of ligands, which is called as spectrochemical series. Generally in the series beginning we discuss I minus, Br minus, next different halogens, SCN minus, next Cl minus, S2 minus, F minus, etc. What is the position of anions children? Beginning. Generally, note right, generally anionic ligands or negative ligands. Anionic ligands have point charges. Point charges. Due to this, generally anionic ligands causes large or more splitting, but the position of anionic ligands arranged in weak field. So that's why this is one of the drawback. What are the first drawback children? Cannot explain the covalent bonding between central metal and ligand. Second, Generally, negative ions are present beginning or end of the series, but the nature of anionic ligands, note down children, generally anionic ligands are point charges and it causes more splitting, but the position, very important, but the position of negative or anionic ligands placed at beginning. So this is also drawback. As per series, these are weak field ligand, but as per nature, it causes more splitting. So this is also one of the drawback. What is the second drawback of crystal field theory? Generally anionic or negatively charged ligands have point charges and they cause more splitting. This is the concept. But in spectrochemical series, in the spectrochemical series, the positions are arranged or placed at beginning or weak field side. So that's why this is also drawback. These two are limitations or drawbacks or demerits of crystal field theory. Crystal field theory cannot explain the covalent bonding between central metal and ligand and cannot explain the position of negative or anionic ligands in the spectrochemical series. As per series, these are placed at weak field, but the nature of these ligands causes more splitting. So these two are drawbacks or demerits or limitations of crystal field theory. Okay children, next very important concept is colors. Colors of coordination compounds. Already explained earlier. Magnetic nature, colors. What are the previous concept children? Generally transition metal ions, metal salts. In aqueous solutions, they exhibit different colors due to, this is oldest topic, DD transition. Generally colors of coordination compounds according to CFT. This is explained by CFT. Just write one introduction. The colors of CC explained are based on CFT. The colors of complex compounds explained are based on CFT. What is CFT? Crystal field theory. For example, why these are colors? Because DD transition. What is DD transition? For example, titanium H2O6 3+. Generally, this is complex entity or complex ion, violet color children. And how many ligands here? 6. 6 means it is octahedral complex or compound. Now what about titanium? Titanium oxidation state is +3. How many unpaired electrons in titanium children? Scandium, titanium. If any doubt, write first titanium. Titanium, it is argon 3d2 4s2. Ti +3 means argon is inert gas, valency shell 3d2 4s2, removal of 3 electrons, hence it contains 3d1. 3d1 means only 1 electron. Now what about this complex children? Octahedral. In octahedral energy of T2Z is less than that of EZ. So that's why this is the electron present in T2Z. Now see, don't write. What is this children? T2Z. This is what? EZ. So this is the electron present in T2Z. It is ground state or excited state? It is ground state. Okay, it absorbs some light from the visible region. Generally it absorbs blue green light. Blue green light. This is what, children? EZ. This is T2Z. This electron lower energy, this is higher. This is T2Z, children. This is what? EZ. Absorbs some energy from visible light. This electron shifted into excited state. Means T2Z set into EZ set. This is what? T2Z EZ. So this electron shifted into this one. So this is called as DD transition. This is one D set, another D set, D to D. So one electron shifted from one set of D to another set. One set is T2G, another set is EG. This is called as DD transition. In this it emits violet color. Okay, children, again repeat, what is the concept name? Colors of coordination compound. This colors of coordination compound based on CFT. For example, TiH2O6 3+, it is violet color complex and it is in octahedral shape. Why? Because 6 ligands. Okay, configuration you know very well. Ti plus 3, 3D1, only one electron. And what about these orbitals? Just 15 minutes back explained, in octahedral complex energy of T2G is less than that of EG. So T2G EG, already one electron. So that's why electron in T2G. This is ground state. Okay, in ground state one or single electron in T2G. But in excited state, excited means it absorbs some light from the visible region and it goes to next level. Next level is what? EG. So this electron shifted from T2G into EG. So this is called as DD transition. Due to this DD transition, the emit color is violet. So finally this entity gives violet color. Finally, therefore, note down, therefore these colors due to are, this is known as DD transition. After writing T2G1 easy. What about this one, children? Ground state. What about this one? Yes, excited state. This is ground state, this is excited state. Ground state, T2G, excited state, electron enters into EG. These two are complementary, children. Earlier we discussed blue-green light. Absorption light is blue-green, emitted light is violet. So these two are complementary colors. And one more very important point, already discussed earlier. What is the condition for DD transition? Single or unpaired electrons only involved in DD transition, whereas D0 and D10 are colorless, does not undergo DD transition. And one more very important, in the presence of ligands only crystal field splitting occurs and colors. In the absence of ligands, the compounds are colorless because no crystal field splitting. Better write one example. See, CuSO4. This is copper sulfate, children. It is almost colorless. Colorless, or sometimes it is white. Both are same. Why? Because no or absence of ligands. So no crystal field splitting. Okay, copper sulfate. This is anhydrated. If any doubt, just write anhydrated. Means no water. Is colorless or white? Why? Because absence of ligands. So no crystal field splitting. Whereas hydrated copper sulfate, generally it is represented as CuSO4 5H2O. It is blue color. What is the color, children? Blue color. Why? Because 5H2O. See here, H2O is ligand. It takes place crystal field splitting. This is explanation of DD transition in the complex ion TiH2O6. Due to this splitting or due to this transition, complex ions are colored. And one more condition, generally anhydrated salts or compounds, anhydrated copper sulfate is colorless or white because absence of ligands. In the absence of ligands means there is no CF splitting. CF means crystal field splitting. And one more, CuSO4 5H2O. This is hydrated copper sulfate. It is in blue color. This is very important in entrance also. Which of the following is color or colorless? It is colorless. It is color. Sometimes assertional reason. Anhydrated copper sulfate is colorless, but hydrated copper sulfate is blue color. A is correct. Or assertion is right. What about reason? It has 5H2O or 5 ligands. So 5 ligands. Hence it causes splitting. So due to this splitting, DD transition, hence it is in color. Okay children. Next, one more. Generally these colors depends on the, already earlier we discussed, oxidation state and the number of ligands. This color depends on the oxidation state of the central metal or number of unpaired electrons in the D subshell. And I will give you examples children. CONH363 plus. Next, this one TiH2O6 3 plus, CuH2O4. These three are different. Okay, here complementary colors. So absorbed color and emitted colors are different. This is complex entity. Entity nothing but sphere. Now next column, absorbed color from the visible region and emitted color or color of the entity, nothing but complex ion. Generally this complex ion absorbs blue and it emits yellow orange color. It absorbs, just now I given, blue green color, but it emits violet, hence it is violet colored ion. CuH2O 4 times 2 plus, it absorbs red but emits blue color. So finally these are the colors, depends on oxidation state or the number of unpaired electrons in the D subshell of central metal. These are complementary colors. Just for reference, write CONH3 63 plus absorbs blue color from the visible region and transmits or emits yellow orange. So finally this complex entity is in yellow color. And Ti, titanium children, just now explained, TiH2O6 3 plus, it absorbs blue green color and emits or transmits violet color, hence this is the ion in violet color. What about tetraqua copper 2 ion? This is CuH2O4, this is 2 plus children, it absorbs red color and it emits blue, hence this complex ion or entity is in blue in color. So finally these colors depends on the oxidation states and the number of ligands also. Okay children, this concept is colors of coordination compounds. So finally the conclusion, these colors due to CFT. Okay, CFT means what? Crystal field theory. Okay, in this crystal field splitting is the one of the important concept. This is colors, nothing but DD transition. This is concept is DD transition. DD, electron shifted from T to Z into EZ by absorbing some energy and they emit or transmits some energy in the form of color. Okay children. And example also important children, anhydrated copper sulfate is almost colorless, but hydrated copper sulfate is blue in color. Why? Because presence of ligands involved in the crystal field splitting. the absence of ligands. No, there is no ligand, no splitting, no color or colorless. Okay children, next concept is metal carbonyls. This is a very important small concept, important for both theory and entrance. Note down children, metal carbonyls. What is carbonyl? Already earlier we discussed ligands. If the complex contains CO as ligand, what is CO children? Carbon monoxide. Then the complex or compounds are known as metal carbonyl. Just write one small introduction. Metal carbonyls. Note down. If the complex or compound contains CO. What is CO children? Carbon monoxide as ligand. The complex contains CO as ligand. It is called as metal carbonyls. What is CO? Better write carbon monoxide. Generally, metal carbonyls are two types: homonuclear carbonyls or homonuclear metal carbonyls. Second, hetero or polynuclear metal carbonyls. Homo means only one central metal. For example, homonuclear. Note down children, NiCO 4 times, FeCO 5 times, CrCO 6 times. Here metal is only nickel, only iron, only chromium. Hence these three are homonuclear. Heteronuclear, Mn2CO 10 times. How many metals here? Mn2, 2 manganese. Okay, hence this is polynuclear. Okay children, once again, what are metal carbonyls children? If the complex or coordination compound contains CO as carbon monoxide as ligand, then it is called as metal carbonyls. Based on the number of metals, these are again two types: homonuclear metal carbonyls and polynuclear metal carbonyls. Homo means only single metal. Example 1, NiCO 4 times, nickel tetracarbonyl, FeCO 5 times, iron pentacarbonyl, CrCO 6 times, CrCO 6 times. These three are homonuclear. Polynuclear means Mn2CO 10 times. Now I will give structures of metal carbonyls. Or examples directly. What is the first example children? NiCO 4 times. Nickel, how many ligands? 1, 2, 3, 4. Central atom nickel. How many COs? Carbon monoxide. This is one carbonyl group, second carbonyl group, third carbonyl group, and this is fourth. This is tetrahedral. Okay children, next FeCO 5 times, second FeCO 5 times. This is trigonal bipyramidal. Iron 1, 2, 3, 4, 5. CO1, CO2, CO3, CO4, CO5. If any doubt, just like PCl5 structure children, trigonal bipyramidal. This is what? It is tetrahedral. NiCO 4 times is what? tetrahedral. This is trigonal by iron. 1, 2, 3. Trigonal by pyramidal. Next, octahedral. CrCO 6 times. Example 3. CrCO 6 times. Chromium, central metal. 6, 1, 2, 3, 4, 5, 6. CO, just octahedral shape. 3, 4, 5, and 6. This is what, children? CrCO 6 times. It is octahedral. All these are different metal carbonyls. Central metal, chromium, children. How many ligands here? Carbonyl groups are nothing but carbon monoxide. 1, 2, 3, 4, 5, 6. Nickel tetracarbonyl, iron pentacarbonyl, chromium hexacarbonyl. Right, this is tetrahedral. It is trigonal bipyramidal. It is octahedral. And last and final, only one, that is poly, Mn2CO 10 times. This is polynuclear. Wait a minute. First we write 2 manganese. Okay, children? Mn. How many CO groups? 10. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mn2. CO 10 times. CO1, CO2, CO3, CO4, CO5, CO6, 7, 8, 9, 10. See, Mn2. How many groups? CO groups, ligands? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is polynuclear metal carbonyl. Why? Because here 2 central metals. Okay, children, all these are metal carbonyls. Tomorrow I will explain the bonding in metal carbonyls, that is synergic bonding. Very important concept. Don't miss the class. Tomorrow I will continue the remaining part in metal carbonyls. Okay, children, thank you. Good luck.
Okay, children. Good morning, children. Yesterday I started photoelectric effect. Photo means light, electric means that is electrons. When light of suitable wavelength or frequency incident on a metal surface, electron emission takes place. That is called photoelectric emission. The emitted electrons are called photoelectrons. The current due to these electrons is called photoelectric current or photocurrent, and this phenomena is called photoelectric effect. So as I explained yesterday, first this was observed by Hertz and later Hallwach, Linard, etc. So yesterday I explained Hallwach observations. Okay,
So in Hall watch observations, three observations are there. One, positively charged zinc plate is taken. Two, negatively charged zinc plate. Number 3, neutral zinc plate is taken. Okay. Now, when light incidents on this is light, UV light. What Hall watch observed? It is already positively charged. When UV light incident on the glass plate, that is a zinc plate, what he observed? Divergence of gold leaves. Divergence of gold leaves. This is first observation. Second observation, when negatively charged zinc plate is taken, when light falls on that, same, when light falls on that, what he observed? Convergence of gold leaves. And finally, he took a neutral zinc plate, okay, neutral zinc plate, and UV light incident on it. What he observed? Again divergence. Divergence of gold leaves. Then why means, see here, it is a positively charged zinc plate. When UV light incidents on the zinc plate, it emits negatively charged particles. Negatively charged particles. As the negative charge is losing, it gains a positive charge. So the positive charge on the zinc plate enhances, increases. So because of repulsion, what happens? The two gold leaves diverge more. Okay. So already divergence is there, more divergence observed. Now he took negatively charged zinc plate. Okay. Generally negative charge means they like this only, diverged only. But when light incident on the zinc plate, it loses negative charges. Means what? Negative charge is decreasing. So divergence also decreases. Okay children, see, if this is divergence, if this divergence decreasing means they will come nearer. So convergence. Okay, that is second case. Now third case, they took a neutral zinc plate. When light incident on that, it is a neutral. Yes or no? There is no divergence, there is no convergence. The two gold leaves like this. Yes. The moment when light incident on the zinc plate, neutral plate, it loses negative charges. So what happens? It gains positive charge. The two leaves gains positive charge. So again repels. So what? Divergence of gold leaves. So later, after the discovery of 1897, in 1897 electron discovery, what they concluded? These negative charges are nothing but electrons. So when ultraviolet light incident on zinc plate, metal plate, emission of electrons takes place, which is called photoelectric effect. Okay children, this is the 3 points, this is a 3 marks question. So whenever ultraviolet light incident on what? Zinc plate, then what happens? emission of electrons takes place, that is called photoelectric effect. Okay. So this is Hall-Watch observation and Head's observation and Lennard observation. And one more thing, children, though UV light incident on zinc plate or any other plates, sometimes electron emission does not take place. Understand, children? Yesterday I told what is the definition. When a light of suitable wavelength, suitable energy, for every metal there is a minimum energy is called what? Work function. Yes or no? The incident energy at least equal to work function, electrons comes out, more also electrons comes out. If the incident energy is less than the work function, then no emission of electrons takes place. They observed, if the frequency of light is less than a particular value, electron emission does not take place. Understand? For 100 marks, what is the pass marks? 35. If you will get 34, you will not be considered as pass. If you will get 33, it is not a pass mark. So greater than or equal to 35, then only you are pass. So what is the minimum marks for pass? 35. Similarly, for all frequencies, no emission of electrons. Understand? There is a particular frequency at which emission of electrons takes place. Below this frequency, no emission of electrons takes place. That also observed by Hall-Watch and Lennard. Okay, children? So yesterday I explained already work function. So what is work function? The minimum energy required to just escape the electrons from the metal surface. Yes or no, children? So see here, W is work function. W is what? What is the lesson name, children? Don't forget this lesson name. Dual nature of matter and radiation. Dual nature of matter and radiation. So work function, W is what? Work function. Now I will take E. E is incident energy. E is incident energy. Means see here, if this is a metal, this is E. Okay, children, this is E. Now if this energy is greater than or equal to work function, electron emission takes place. Yes or no? Electron emission takes place. Electron emission takes place if E is greater than or equal to W. Yes or no, children? It's very important. If work function is 1 electron volt, if incident energy is 2 electron volts, see here, E, W. Okay, children? Now E, W, I will write here 2 electron volts in all cases, 2 electron volts. Now incident energy is 5 electron volts. Electron emits or not? Yes, electron emission takes place. Yes, now incident energy is 3 electron volts. Electron emits or not? Yes, because it is greater than that only. Yes or no? Now 2 eV. Yes or no? 2 eV. It requires 2 eV for just emission. So no problem. Now if it is 1 eV, if 1 eV is incident, 2 eV is work function, then no electron emission does not takes place. Here also emits. So what is the condition for emission of electrons? At least E greater than or equal to W. Okay. So we have E equal to h nu. Is there no? So we can write this h nu greater than or equal to W. Send this h this side. Nu greater than or equal to W by h. So the frequency of incident light must be greater than or equal to W by h. If this frequency is less than this value, no emission. Yes or no, children? See, so pass marks, not pass marks, for passing, greater than or equal to 35. Yes or no? For pass. Then what is minimum? So pass minimum how much? 35. If 36 also pass only, 37 also pass. If it is 34, then you are not considered as pass. So the minimum frequency below which there is no electron emission takes place is called threshold frequency. A new word came now. First of all, say nu greater than or equal to W by h. Then minimum is what? Minimum equal to W by h. This minimum frequency is called threshold frequency. This minimum frequency is called threshold frequency. Threshold means limit. Understand, children? So that is indicated by nu naught. So nu naught equals to W by h. We know W work function, h is Planck's constant. Yes or no, children? So now what is the threshold frequency? The minimum frequency below which there is no photoelectron emission is called threshold frequency. The minimum frequency below which there is no photoelectron emission takes place is called threshold frequency. Okay, the minimum frequency below which electron emission does not takes place. Is called threshold frequency. Understand, children? So now see here, what is nu? Nu is the frequency falling on the metal. If this frequency is greater than threshold frequency, electron emission takes place. Yes or no? If incident frequency is greater than this minimum value, emission takes place. Means 36 marks you will get pass. Now, if nu is equal to nu naught, means if you will get 35 also pass. If this frequency is equal to this frequency, then also emits, electron emits. If this frequency is less than nu naught, then if you will get 34 or 33, it's not a pass. So, no, not emits. Yes, children? Why means to eject the electron from the metal surface, it requires some energy. Yes or no? Greater the energy, greater the frequency. Lesser the frequency, lesser the energy. So, energy frequency directly proportional. So, this is very important. What is the point here? What is threshold frequency? The minimum frequency below which there is no electron emission takes place, or the minimum frequency at which electron emission starts. Yes or no? Where it starts, at that particular frequency starts. If it is more also, starts only. But I think some students may get doubt. See here. See. If 2 EV incident, work function also 2 EV, emission takes place. 1 EV, no emission. 3 EV, for at least for emission 2 EV, but incident how much? 3. Then what about that 1 EV? The remaining is what? Remaining is what? Kinetic energy. Yes or no? If you will get 35 marks, any student get 35 marks, just pass. Yes or no? Just, oh, you pass, that's all. If you will get 40 marks, that also pass only, but the 5 marks to tell, I got more than 5 marks, more than pass marks. If you will get 90 marks, 55 marks more than pass, that is also pass, but you will get appreciations. Here appreciations is nothing but kinetic energy. Okay, 10 EV incident, 2 EV for emission, but remaining 8 EV kinetic energy. Understand? So, if 2 EV incident, 2 EV work function, no kinetic energy. Just the inside electron will come just like that. It will not move. It will not have any kinetic energy. But if you give more than that, it moves. So you will get current. The flow of electrons is called what? Current. So these are all observations done by Hallwach, Linard and Hertz. Okay. So now we want experimental study of photoelectric effect. Understand, children, what is threshold frequency? The minimum, don't forget this word, minimum frequency below which no electron emission takes place is called threshold frequency. This threshold frequency also depends upon nature of the metal, different for different metals. Yes, sir, like work function, because work function and threshold frequency are nearly same. See here, directly proportional. W equal to h nu naught. H is Planck's constant. Okay, so the minimum frequency below which electron emission does not minimum below, these words are important. Okay, right children? So now we will start experimental study of photoelectric effect. Experimental study of photoelectric effect. The concept is experimental study of photoelectric effect. Okay children, so for this experimental study of photoelectric effect we want some apparatus. What we want? See here, first of all it requires evacuated discharge tube. See here. This is evacuated discharge tube provided with quartz window. Provided with quartz window. So this is quartz window. Through this light will fall. Okay, and the two ends are provided with two electrodes. The two ends are provided with electrodes. This is cathode. This is a cathode and this is a anode. Two are metal electrodes, cathode and anode. This is anode. This is a anode. Okay. Now, and here you have to supply potential difference, means battery is required, and to vary the potential difference we want potential divider called rheostat. To measure the current we want ammeter. Okay, see here. Okay children. So this is a ammeter, microammeter, mu A. Okay. And to measure the potential difference, this is voltmeter. To measure the potential difference, this is a voltmeter. Okay children. The potential difference between cathode and anode can be varied, can be changed by using rheostat, that is called potential divider. Potential divider. Okay children, this arrow mark is there, you know, this is called rheostat, RH. rheostat. Okay, and see here. I will tell what is this. See here. Okay, children. See, this is a schematic diagram of experimental study of photoelectric effect, and here one setup is there, RS. This is battery B, rheostat, voltmeter, ammeter, and this is a window. This is window for what? To incident light here. Okay, children. So now C. What is C here? I will write here everything. C. Cathode. We know cathode is a negative electrode. It is a negative electrode. Okay, children. This is also known as emitter. It is also known as emitter. Cathode is also known as emitter or photosensitive material. It is. Cathode must be photosensitive material. Means what? When light incident on it, you should get what? Electrons. It is a photosensitive emitter or material. Okay. Now A. So A is what? Anode. A is anode. Okay, anode is positively charged. Positive. Yes, children. Now see, when light incident on cathode, it emits what? Electrons. That electrons are travelled towards anode. It collects electrons. So it is also known as collector. It is also known as collector. Okay, children. So A is anode or collector. Okay, and this RS is called reversing switch. It is called reversing switch or commutator. To reverse the voltage or to reverse the direction of current, we are using reversing switch. Later I will tell what is the purpose of this. And RH is called rheostat. Another name, potential divider. Potential divider. Okay. Now you know what is V? Voltmeter, which measures the potential difference between cathode and anode. This is microammeter, which measures the current in this circuit. Okay, children. So this is the arrangement. In examination, if you will not draw this middle also, no problem. Okay, no problem. What is the main things here? You know, this window, this discharge tube, cathode, anode, microammeter, and you can give directly to what? Battery. Without battery, nothing will happen here. Understand? Okay. See here. So this is the experimental arrangement. Okay, children. So don't worry by seeing this diagram. Okay. So here what is the main things are this and this last part. If you will not draw middle part also, no problem, but some purpose is there here. So now after this diagram, just listen carefully. Okay. First of all, this discharge tube is made up of quartz or glass. It contains a discharge tube made up of quartz or glass. It is provided with a quartz window. It also made up of quartz because it is transparent. Quartz window. And the two ends are provided with two electrodes, cathode, anode. This is cathode, this is anode. Cathode is maintained at negative potential, anode is maintained at positive potential with respect to cathode. See here, this is which terminal? Positive terminal, and this is negative terminal. This positive is given to whom? See here, just a connection, see where it is given? A. So A is given to whom? Positive, and B is given to whom? Negative. Negative, very important. This is a negative electrode, this is a positive electrode. Anode positive electrode, cathode negative electrode. Okay. Now see here. Consider a monochromatic light. Monochromatic light means what? A light of single wavelength. A light of single wavelength or frequency. Okay. So take any light, either UV or blue or yellow, like that. Okay, children. So whenever light passing through this window falls on the metal plate, so what happens? Electrons emission takes place. Electron emission takes place. Electron emission takes place. Okay, children. So when light incident on the metal surface, cathode, it emits electrons, and these electrons are having negative charge, and these electrons attracted by the anode, because it is given which potential, children? Positive. First positive potential is maintained. As it contains positive potential, these electrons are attracted by the anode. As the circuit is closed, okay, you will get some current in the ammeter. A small amount of current flows through the micro ammeter. Understand? This is the first observation. Okay. See here, when no light on this cathode, no current in the ammeter. When light falls on the cathode, it emits electrons. These electrons are attracted towards, travel towards anode, and you will get some current. This current is called photocurrent. This current is called what? Photocurrent. These electrons are called what? Photoelectrons. This is a fundamental observation. So now you want to know about how intensity of light changes the current. How intensity of light changes the current, which is very, very important. Okay, children. Just take a screenshot, children, because I will rub all those parts. Okay. So what is this, children? RS reversing switch. Later I will tell why that is purpose. Okay. So if you reverse this, this anode becomes negative. Generally anode is given which potential, children? Anode is given positive. If you connect this here, anode maintains a negative potential. So reversing switch. Another name is called what? Commutator. Okay. So now next, which is very important conclusions you will get here. See children, first of all, effect of intensity on photocurrent, which is most important. Effect of intensity on photocurrent. Now, first of all, this effect explained on the basis of collisions between light and electrons. Generally, collisions takes place between what? Particles. Yes or no? Here, light also considered as particles called photons. You know, I think photons. So this is nothing but collisions between photon and electron. Yes or no? So now, what is intensity? Okay. For example, so if you enter into a bright room from dark, suddenly if more light will fall on the eye, you feel inconvenient. Yes or no? You feel inconvenient. You will close your eyes because more light is incident on your eyes. What is the meaning of that? You know, more number of photons entering into your eye. So that is brightness. More number of photons in 1 second. In 1 second, 1000 photons will enter. That is nothing but bright. High intensity. If 2 photons enters in 1 second, low intensity. Yes or no? Here. See children, so intensity is nothing but number of photons per unit time, per unit area. See, what is this children? This is light. So light is coming from a source. This is the source. Yes or no? So high intensity, low intensity, like that we have. Then what is intensity? Just see this diagram children. See here, I will take a small area. I will take a small area. Yes. Now I will put one dot. Just one dot. Any brightness is there? No. Now children, brightness increased. Yes sir children. Now children, number of dots increased, intensity, brightness also increased. Yes or no children? Now again see. What happened children? Again more number of dots increased, brightness also increased, intensity increased. So what is the relation now? Intensity is nothing but number of photons per unit time, per unit area. Understand children? So more number of photons are there means high intensity, less number of photons means low intensity. Okay children? So intensity of incident light, intensity of incident light. You know what is this children? This is nothing but number of photons per second. per second per unit area. Forget unit area also, just remember intensity of light means number of photons. Okay, if one photon incident on this metal, it extracts one electron. Yes or no? If two photons incidents, it extracts two electrons. If 10 photons incidents, it extracts 10 electrons. Electrons are increasing means current also increases. Yes or no? So if you increase intensity, number of photons increases, number of electrons increases, thereby current also increases. But here condition is there. The frequency must be greater than the threshold frequency. We know that already. Yes or no? Yes or no? Potential fixed. Potential difference fixed. Frequency greater than threshold frequency fixed. Now change the intensity of light. Okay. How you change intensity of light? Tell. Take one torchlight. Take one torchlight. So focus here. Brightness is there. If you move far away from the board, what happens? Intensity of light on the board decreases. Means what? Less number of photons are incidenting on the board. Understand, children? Sometimes if more sunlight falls on, we feel high intensity. Means what? More number of photons are entering into the eye. Sometimes less number of photons entering into the eye. Low intensity. So don't forget, very important. Intensity is nothing but number of photons per second. If you increase intensity of light, number of photons increases, number of electrons increases, thereby current also increases. Means what? Both are directly proportional. So intensity of incident radiation increases what? Current. So current, I means what? Current is directly proportional to what? Intensity. Understand, children? So one thing, that intensity refers to number of photons but not their energy. Energy intensity different. If you increase intensity, 10 photons maybe become 20 photons, but energy same. Why? Frequency fixed. Understand, children? So in the next class I will continue. If you have any doubt, you can send through WhatsApp. I will clear your doubts. Okay, children? So intensity, remember, number of photons per second per unit area. Okay, children? Right.
Privacy security.
Good morning, children. We are continuing biodiversity, and today we will see loss of biodiversity. It is alarming rate. The way the loss of biodiversity is taking place, it is unimaginable, and we will see how it is in the past. Even when there were no human beings, there used to be very big mass destruction of or mass extinction of species, but none of them were so dangerous as it is going on today. As on today, what is there, what loss we are incurring in terms of species is terrible, and that regarding that in detail we will be seeing in different cases. Different numbers are there, and those things we cannot even imagine. Now, loss of biodiversity we will see now when loss of biodiversity has taken place. Is that clear? Now, very first thing, one of the reasons we will see that colonization of Pacific Island caused extinction of 2000 bird species. What is this colonization of Pacific Islands? We all know Pacific Ocean is a very big ocean. In that, a large number, uncountable number of islands are there. In all these islands, most of the places actually human reach also is not there, but whatever the reach it has made, and to those places when human beings were sent, and that was converted into a colony of living organisms as well as the human beings. Newly, because of the population, new places are sought after, and their number increased. Human beings, they came up and they started forming colonies. And this formation of colonies is nothing but colonization. Pacific Islands were used, which was earlier not, human beings were not living. But once it started, we saw that there was, only due to this colonization of Pacific Islands, about 2000 different species of birds were extinct. One can imagine what a big loss for biodiversity. In the past classes we saw importance of biodiversity. If biodiversity is there, if community is maintained, then only there will be biodiversity, and if biodiversity is there, then all of us can sustain for a long period. Otherwise, all of us are at risk. You see, only one action of human beings has caused such a loss. 2000 different bird species were lost in the Pacific Islands when they were colonized. Second thing is there is an organization called Iucn. You know this, we have already talked about it before also. International Union for Conservation of Nature and Natural Resources. This is the full form. I am repeating once again. International Union for Conservation of Nature and Natural Resources. And this organization is keeping an eye on the entire world's biodiversity, and how they are affecting, how they are getting closer to extinction and all. And they usually produce books of lists of organisms that are endangered, that are extinct, that are closely moving towards endangered condition, those who are vulnerable in nature. All different categories they are listing and producing, publishing, so that human beings will be aware of this and will take care of their actions. Now, they have in 2004 produced a red list, or a list of things which are already extinct. You see, they have given that about 784 species have been extinct in the last 500 years. In the last 500 years means human beings, we are here only, very recent it is, isn't it? We have got history records, we learned everything. By that time we knew how to write, how to read, what is good, bad, science, everything. So many things had come that time, and in spite of that, about 784 species. Student, these numbers are very important, you have to note down. This could be asked to you as 1 mark question, and in the long question also, these are all data. If you don't reproduce, then there is no question of getting marks. So please give full attention, make your pen and pencil, write on your notebooks. So simply don't listen to me and write, and afterwards you again read the textbook and then compare, and then finally make a note and keep that for preparation. Second thing, every day I used to tell, all the last year I have told you that whether it is first year or second year, reading of biology is always line by line, word by word that is present in the textbook. The recent NEET result also, we saw that almost 98% of the questions were only from the textbooks, and only 1 or 2 questions they came outside, but they are indirectly, they are also related anyhow. But if you only complete your textbook line by line, word by word, then there is no question of not getting a very good percent in biology at least. Am I clear? So please don't neglect, don't take it easy and be serious. Another thing is, these things what we are doing is will not be repeated. Probably this I am telling you in every class will not be repeated. So give your full attention and be prepared that this is the final teaching for you, and after that there will be NEET level. NEET level you all know that is level of NEET is different, teaching pattern will be different. Like this, one by one, line by line, word by word, we may not be able to cover that at that time. That coverage will be different. That's why please pay. Without PU knowledge, NEET you cannot do, CET you cannot do. Keep this in mind. So PU is the basic tool, basic key for success. First thing. Coming back to this, about how many in the last 500 years, red list says that Iucn has produced. In that we saw that 784 species were lost. And what are those 784 species? They are 338 vertebrate species. Like this also questions can come. In the last 500 years, how many vertebrates were extinct? Means your answer should be 338 vertebrates according to Iucn. According to Iucn. Similarly, 359 invertebrate species. Invertebrate species are 359 invertebrate species. And plants, coming to plants, about 87 different types of plant species were extinct in the last 500 years. You can imagine how big thing. In one attempt here we have lost 2000 different bird species, whereas here in the last 500 years, due to our activities, human activities, anthropogenic activities, anthropoid activities, we have lost 784 species. In that, 3 categories they have taken. One is your vertebrates, which is 338, and another one is the maximum number invertebrates, that is 359, and the plants were about 87 different plant species were lost, and they were lost for us, for our activities, human activities. Now next, recently, which we have seen recently, more or less in our generation only, we have seen that they are grouped under recent, that is in Mauritius, dodo is a bird actually. It is a duck-like bird. Dodo is a duck-like bird. Now in Mauritius, this got extinction in front of our eyes. Means many of us must have seen this dodo live world over. In Mauritius, those who were there and those who are now today there, they must have seen dodo live walking on the earth, and now they were one of the beautiful birds, that is dodo, and they got extinct by our action. Do you know what is the reason? Simply human beings killed them and ate them. For eating, thousands of varieties of food is available, but we were so interested in dodo that we killed them all, and today there are no dodo on the earth, and they were only present in Mauritius, and they were gone. So please remember, you may be asked the country's name, you may be asked the bird's name, understand? Or under recent head, what are the animals are included, that also they may be asking. For table also it can be used, direct question also it can be used. Table like dodo on one side, Mauritius on maybe on the other side. So take care, very important. Second one comes quagga. Quagga is actually in Africa, it got extinct in recent years only. I am giving you a list of recent years organisms which were extinct. First one was dodo in Mauritius, quagga in Africa, and thylacine in Australia. Thylacine actually once it was one of the most abundant carnivore, remember. Once it was most abundant. This line is very important for you. It was once most abundant carnivore. This thylacine, they were exactly not wolves, but they will be like jackals or wolves or something like that, and they are dog-like, bigger dog-like size and all, and they were their number was very huge. They were plenty, most abundant in the nature, and in Australia they were actually completely extinct. Today there are no thylacine. Similarly, stellar sea cow, one of the beautiful animal that lives in the water, and it is found in Russia, and today no stellar sea cow are found in Russia. They were also extinct in the recent times. Remember, this all I am relating to recent times, so that is very, very important. You have to remember all the names: dodo, quagga, thylacine, stellar cow. They are found in Mauritius, Africa, Australia and Russia respectively. Now, after seeing this, one more very strange thing you will find: tigers. They used to be, actually they are all powerful, we say, they can kill animals and eat, we say, but see, it is due to anthropogenic activity, human activity. 3 subspecies of tiger got disappeared on the earth. From the earth they are not seen anymore now. Today there are no tigers. Some tigers, 3 subspecies of tiger. What are they? One is Bali. Bali is a subspecies of tiger. Javan, Java and Bali, these 2 are islands, you must be knowing, you should know. Java and Bali, and there the tigers which were found, they are subspecies of tiger. Very special to Bali only, very special to Java only, nowhere else they were found, and in these places they were eliminated. They became extinct. One more subspecies is Caspian subspecies of tiger, that was also extinct. Remember, the 3 subspecies of tiger which were extinct can be given you in table manner. They may give you direct questions, multiple choice questions. So remember, or place, they may give you Javan tiger is found where, or the dodo is found where, or thylacine found where, like these questions can come. So don't neglect it, write down all the names. Next one we will see. It is surprising, in 500 years we saw this many, 784 species got extinct in 500 years. But you see, in the last 20 years we have killed all the animals of 27 species. So is it not a very fast? Means earlier when nobody was there, no science was there, nobody was taking care, by that time it was rather slow. But after our inclusion in the biodiversity, when we came, from that time onwards the destruction of animals or the biodiversity is much more. Remember, in last 20 years we have made extinct to 27 different species. Remember, this is very important. In the 500 years we saw, these are some of the things, what? 784 species we saw in 500 years, but in 20 years we have killed 27 species. So convert, if it is 500 years, this type of thing means what will be the number of species, you can imagine. Now next will come, out of all these different types of animals, we all know that amphibians are actually what? Defenseless. Defenseless means they don't have anything to bite so that people will be away. They do not have very strong claws or something so that they can tear or they can scratch the people. They don't have anything. They are not covered by scales or anything so that they can protect themselves. So they are one of the most defenseless animals. Is that clear? So remember, that is the reason why amphibians are more vulnerable, very easy to get extinct. Amphibians very easily get extinct because they are very vulnerable. They are defenseless. They cannot protect themselves unless until they are protected or they are left to themselves. But we don't do it. We go on killing them, some intentionally, some without intention, but whatever it may be, it is human action or anthropogenic action. Keep it in mind. This word anthropogenic means activities of human beings. Activities of human beings. Now next, more than 15,500 species worldwide on the verge of extinction. Now, who are already extinct we saw here. Now, those which are on the verge of extinction, a line, if they are not taken care of, the line is what? Taking care. If that taking care is not there, then within short period, we are going to lose 15,500 species. They are all on the verge of extinction. Their number has come down. Their population is so less in different parts. Very small number is there. If they are killed, then they will be erased from the earth's biodiversity. Is that clear? So more than 15,500 species worldwide are on the verge of extinction. This is a very important data you must remember. Next we'll see presently out of these 15,500 what percentage of animals or plants they are on the verge of extinction. To that only we are dividing here in terms of what percentage. 12% of birds are at risk. 12% of birds are at risk. They can be eliminated at any time. Similarly, 23% of mammals, they are also at the verge of extinction. Then comes 32% of amphibia. Just now I was telling you that they are very much vulnerable to extinction, and they are 32%, whereas mammals are 23% and birds are about 12%. Next one we will see 13% of gymnosperms. 13% of gymnosperms. So please see once total yourself this percentage how much it is coming. 12% birds, 23% mammals, go on adding, then 32% amphibia and 13% gymnosperm. Total is how much? Total will be, let us add it. One is 12%, one is 23, and then one is 32, one is 13. 3 to 5, 5, 10, 0, 1, 1, 2, 3, 5, 2, 7, 1, 8. So about 80% information is given, and still many more are there which we are not still able to find out what percentage they are at risk. Anyhow, so remember these percentages are also equally important. You may be asked separately what percentage of birds are at risk today. It is your 12%. Anyhow, now next thing we'll see, that is if we go back to our history, from the origin of life and evolution, when it started taking, different organisms came out. That is very, very old. And how do you find out those things? We find out that by studying the fossils. Study of fossil is called as paleontology. I believe you know. Paleontology. Write down study of fossil is, here I am writing Paleontology. This is the branch of science in which we study the fossils. We study the fossils. Spelling I'll repeat. Paleontology. Paleontology. Paleontology is the study of fossils. Now this, by studying the fossil, the remnants, the bones, the prints, the other parts of the body, imprints in the stones and rocks, after studying all of them, we saw that there were there were too much of number of species were there. The biodiversity was very, very rich on the earth, very, very rich. Understand? And this study is not today, it is studied how much more than in the last 3 billion years. More than last 3 billion years study it is. Remember, means soon after the origin of life, then origin of animals and plants, and then came, they started forming different species. So the biodiversity started from that point. From that point, the whatever we have got fossils, everything we study, that is how much time? More than 3 billion years. More than 3 billion years study when we make, we found that there were 5 big mass extinctions. There were 5 big mass extinctions. In how many years? It is more than 3 billion years. Is that clear? So billion years means is a very big number, we all should know. 3 billion years, there were 5 episodes of mass extinction. And after that, the present age, today, in this present age, after we all came, human beings came, the present one is the 6th mass extinction. Today, the mass extinction is going on, and that is the 6th mass extinction. Let's remember this. Earlier there were 5 and the present one is 6. That is 6th one. So total how many mass extinction periods are there till today? It is 6. and in the past, how many were there? 5 were there. So 5 mass extinctions episodes were seen in the past, that is in the time more than 3 billion years. But now, in a very short time of the present age, the 6th mass extinction is going on. Now, of course, there should be a question that were those mass extinctions were bigger ones or the present one is a larger one? See, surprisingly, nobody was there to protect, and they were facing the environmental, any problems, disasters, any problem they were facing. Still, in those last 5 mass extinctions, what extinction was there? And if you compare with the 6th one, the rate of mass extinction is very fast. Means in a particular number of years, the extinction is much more. Then how many times it is more? It is 100 to 1,000 times more faster. Remember, the present day mass extinction is 100 to 1000 times faster than the previous 5 mass extinctions. In the previous mass extinctions, actually at what rate, at what speed, what number per time they were becoming extinct. Today, with all our knowledge, all our science, every facility, every reasoning, thinking power in us, the present day we are killing them and they are meeting extinction at 100 times more to 1000 times more. In different species, if you study, nothing is less than 100 times more. They are all 100 times more. Extinction is happening now. Or some species are there, they are 1000 times more quickly they are meeting their extinction. So you please imagine which is the greatest mass extinction. Definitely the present one. This way also questions can come. So now, this is the most terrifying, fearsome mass extinction, the present one. And remember, this such a terrifying and fearsome mass extinction is taking place, that is 100 to 1000 times more faster rate. And this is purely due to anthropoid activity, anthropogenic activity, human activities. All the 3 are same. Due to human activities, this has happened. So, definitely, it can be concluded that for the present high rate of mass extinction is only due to us, only due to human beings. Okay. Now, next we will see, if this rate of mass extinction is going on, if this way, at what rate it is there, if it will continue, then what will happen? Half of the total species would disappear in 100 years only. Means such a huge biodiversity, beautiful biodiversity we got in more than 3 billion years. We got it in more than 3 billion years. And if we will not open our eyes, if we will not take care of it, and we will allow this mass extinction like this only to go, then within 100 years, half of the total biodiversity will be eliminated. They will meet their extinction. Half of the total biodiversity will be eliminated in just 100 years. 100 years means what? Maximum 1 or 2 generation. Only 1 or 2 generation. So today every person should be cautious about that. Everyone should be aware of that. They should not unnecessarily kill animals. They should not kill animals just for luxury sake, just for showing their money, just for decorating their house. It should not be done at all. Only we should take that much which is our need, and we all know nature provides us enough for our needs, and for our greed, not nature, nobody can provide us anything. Greed is unlimited, it has no end at all. Anyhow, so please remember, this is a warning indirectly. If this rate, the way we are behaving today with the biodiversity, if we continue to cut the plants, if we continue to kill the animals, then within just 100 years, 100 years means people say, okay, 1 generation, but let me tell 2 generation also. One father today and his son son tomorrow. So these 2 generations, by the end of 2 generations, half of the biodiversity will be eliminated. And you should think that half of the biodiversity, if it is eliminated world over, then how much shortage, how much need, how much want will be there on the earth. People will suffer like anything. And maybe the human life on the earth may be endangered also. It is not impossible. So that's why one should be very, very careful, and that is why this line is of extreme importance. Okay. Now next thing we will deal. We have talked about all these things. Then first we should also know that what is the importance of this biodiversity. That species, why if they are not there, what will be the problem to us? So there are 3 effects are there, and if we are not maintaining the biodiversity, we are not protecting the biodiversity, or not conserving the biodiversity, then what will happen? There are 3 important things will happen. One is there will be decline in plant production. See, plant production, to be frank enough, almost all organisms on the earth are dependent on the plants alone, because they are the only organism who can synthesize food. None of us can synthesize food. Only green plants, basically green plant, they are only capable of synthesizing food, and other than that, no animal is capable, including human beings, capable of synthesizing or producing food out of carbon dioxide, water and sunlight. We don't have that. So that means we have to be very careful. The plant number should always be maintained, otherwise the entire animal present on the earth will be eliminated. But if we are not taking care, then the plants will be eliminated. There will be decline in plant production. If plants are less, then plant produces also will be less. The food what we are eating will be less, but our population is day by day increasing. So there will be a alarming condition, dangerous condition. Now second thing is lowered resistance to different environmental crises. See, it is nature. In different times, different types of environmental crisis may be there. For example, there can be disease, there can be drought, there can be flood, there can be volcanic eruption, there can be what is that called, earthquake. Like these different types of nature's catastrophes may be there. So those things are not under our control, and in those conditions, if the number of biodiversity is very high, then even though due to those conditions some are eliminated, still the leftover will be sufficient enough to support us, support our existence on the earth. So that will be at risk. What? Lowered resistance to drought, etc. means environmental crisis if they come, natural calamities if it comes, then if biodiversity has come down like this, then resistance will be less and all of them may be eliminated. Third important thing is, here what happens? Increased variability. Of course, the variability will be increased. If large quantity, out of that if 50% are gone, extinct, whoever are left, their number will be less, their variability will be much different from one another, and variability will be increased, and once they increase, they will not be able to face their nature. Then comes what? In water use, some of them, they cannot use the water. Understand? Similarly, their plant productivity will come down. Similarly, pest or disease cycle. Pest means what? It can be your different insects or different other organisms attacking the plants. So if their number is more than the small attacks by nature, natural way, that will not be very much significant. But what will happen here? That also will decrease. Management of pest and management of disease cycle by these plants will come down, will be very less. And please remember, if plant productivity, plant resistance, plant's viability is not there, then there will not be any animals, and of course human being is also included under that. Our existence is also at risk. Next we will see, if it is so important, we must know what are the causes. What are the causes of biodiversity loss? Why? What makes to lose biodiversity on the earth? Now we will see causes of biodiversity loss. Now we will see losses, biodiversity loss, why it is taking place, what are the causes. And here we are given that these causes are purely anthropogenic activity. It is purely, all the causes that I will tell, they are all related to anthropogenic activity only. No animal, no other plant is destroying the biodiversity, all of us know. Everything is happening due to our activities, human activity only. Anthropogenic activity means human activity. And now we will see what are they. There are 4 major causes are there. There are 4 major anthropogenic activities are there. How many? There are total 4 anthropogenic activities are there. Number 1 is habitat loss. Second one is your over exploitation. Third one is your introduction of alien species. Last one is co-extinction. I'll repeat once again. First one is habitat loss. Habitat loss means cutting the jungles, the home of the animals, and plants are cut means that the home of plants also is removed. So first one reason is that, and you know, no animal goes and cuts the plants or trees. No animal kills another animal unnecessarily. They kill each other only for the what? Food chain, because if they don't do, they cannot survive. But once their belly is full, they are not going to kill other animals unnecessarily. So that is why first one is habitat loss done by human beings only. Second one is second one is over exploitation. Over exploitation is what? We all go kill animals for our benefit. We kill the entire such a beautiful animal, that is elephant, only for its tusks. Imagine what an unfortunate thing. How much we are thoughtless, how much we are brainless fellows you think of. We are killing the beautiful tigers who are the key species in the jungle, in the biodiversity. We are killing them for their hide, their skin. And that skin use is not much, but without that also we can manage. But we do it, we take it, and we unnecessarily misuse it. So that is over exploitation, means we don't need to kill a tiger for our survival, but we do it. We don't need to kill a peacock, but we do kill it. It's not necessary. We have other sources of food also, but we just kill out of fantasy, out of our unnecessarily brainless ideas. So over exploitation. Third one is, and the last one is, third one is introduction of alien species. Introduction of alien species is what? For our benefit. We want big fish, more flesh in that, more money by selling. Indian ones or any local ones, they are not of that size. Then we bring from some other country, introduced into our ponds and other things. So what happens? They are actually aggressive ones. They will grow and they will kill the native ones. So for the existence of one species brought from another place, that is alien species, we are killing hundreds and thousands of local species. That means biodiversity is affected. Now the last one is there, that is your co-extinction. The fourth one is co-extinction. You all know there are many relationships are there. We have already completed, like you have got commensalism, you have got mutualism, you have got parasitism. They are all species specific. One particular species and another particular species only, they will be living together. They are not going to live with anyone. So what happens? Particularly in mutualism, if one species is dead, automatically the other one is going to be also dead, because they will not get the one with whom they do mutualism and they survive. Mutualism is an association which is important for survival. Remember, both of them, if it's there, then both of them will survive. If one is not there, both of them will die. Similarly, parasites. Parasites are always host specific. In one particular type of fish or in one type of animal, you will see thousands of parasites will be there, hundreds of different types of parasites may be there in him. So when we are killing that particular fish or that particular animal or organism, all those parasites who would have stayed in their body, all will be extinct. So imagine how much we are destroying. We feel that by killing one nothing will happen. No, it happens. So we have no right to kill or cut the plants and animals of biodiversity. Okay, one by one I will explain these things. Very first one is your habitat loss. Habitat is house. If we are kicked out of the house, our house, it is very difficult to survive. You imagine rainy season, you for 3 months, 4 months, you always get wet and remain in moist condition all the time, completely drenched condition. Can we survive? No, we can't survive. So that's why, like that, there also, if you remove their house, then there will be definitely death of biodiversity. Now let us see most important cause. Remember, habitat loss is out of these four most important, topmost, that only kills the maximum number. The most important cause, any cause, four causes, these four only are given, and you will be asked which is the most important. You should talk about habitat loss, or any other combination they give, any other word they give, any other thing they give. Which is the most important cause of biodiversity loss? It is habitat loss. Okay. Now tropical rainforest, all of us know, we have studied in the past that was to use. In the past, scientists have found out that about 14% of the land of the earth was covered by tropical rainforest, and today we have only 6%. You imagine 6% is of what size today? It's very huge. We were calling it as what? Lung of the planet we were calling. And but you imagine, earlier it was 14%, means more than double of this, 2.5 times roughly, means actually how much it was there. We people came, reduced it to 6%. Next, now what is happening, I am telling, we are removing about 1000 hectares of tropical rainforest every 1 hour or 2 hours. In 1 or 2 hours, we are removing about how much? 1000 hectares. It's not a less thing. Similarly, Amazon is one of the tropical rainforest only. As I told you, it is treated as lungs of planet. And now millions of species are there. We have already studied, when I taught you about Amazon basin, what animals are there. One of the conclusion is about more than 2 million species are still to be discovered, found out, named, identified. We don't know what is their name. We are yet to do it. So many are there. So what we are doing, millions of species are there. If we are cutting this jungle, Amazon jungle, for soya cultivation, soya bean, you know, for soya bean cultivation we are doing. See, only a very small group of people are benefited, that also monetarily, but they also suffer, we all also suffer due to lack of biodiversity. And there actually hundreds of acres are cut every day. Next one is why, this one reason is why they are cutting. One is soya cultivation. Second reason is conversion into grassland. I mean, those jungles are cleaned and their grass is grown, so that beef cattle, means cow, ox, buffalo, all these are beef cattle, to raise their number so that more flesh will be there. So remember, this is also very wrong. For only a certain group of people, the entire world is suffering and the planet is at risk. Now next, is this only this much? When they are cutting all these things, they are using different types of instruments, machines, and from that lots of pollution, sound pollution is there, that is called noise pollution, then other dust pollution is there, and still many more pollutions are coming, and pollution also threatening to those animals. Remember, pollution also is threatening them. Am I clear? So many organisms are there, they cannot tolerate sound, and noise pollution can kill them also, because they never heard those things there since centuries, since millions of years. Next, mainly this cutting and all affecting to whom? Birds and mammals. Mainly it is affecting to birds and mammals. And the reason is, main reason is what? Main reason is actually they have, or they require very big territories. They need a very big area for them. Anywhere in that area there is disturbance, they cannot survive. So mammals and birds who require large territories, remember, they require large territories, and they are migratory. Many are there, they are migratory. They will be moving from one place to another place, again they will be coming back. But while they come back, these people might have cut their jungle. Imagine where will they stay? And they cannot enter into others' territory. There will be unnecessary disturbance, fight, competition. So that is why this cutting and all is risking bird number and mammal number very much. And the reason why they are affected, because they require large territories and also they are migratory in nature. Right? Now, next class we will be dealing with other two and how to conserve. That also we are going to do it in the next class. Okay, thank you very much. Take care of yourself and do study.
Right, children, good morning. So I will continue the properties of alcohols. So we are discussing oxidation properties of alcohols. In that we have seen the primary alcohols. Just I will recall one or two points and I will continue that oxidation properties. You know that alcohols are oxidized in two stages. In the first stage, alcohols are converted to aldehydes, and in the second stage, aldehydes are converted to carboxylic acids. So in this, when you are going to use the strong oxidants like chromic acid, CrO3, again KMnO4, then the alcohols are all the way converted to carboxylic acids. For suppose you want to stop the oxidation at the first stage of alcohols, that is, I want only aldehyde. I don't want to oxidize aldehyde to carboxylic acid. In this particular case, we have to use the oxidants which are mild. So for that, the best reagents are PCC and PDC, that is pyridinium chlorochromate and pyridinium dichromate. These are the two oxidizing agents which can oxidize alcohols into aldehyde stage but not to carboxylic acid stage. Again, one more advantage of PCC is it can oxidize only alcoholic group, that is OH group, without touching the double bond. So if there is double bond, that is unsaturation in the given compound, that will not be oxidized by this PCC. Only OH group is oxidized to CHO group. So these are the points we have discussed. Now we will see the oxidation of secondary and tertiary alcohols. So oxidation of secondary alcohols. If you take a secondary alcohol RCH, OH, R dash, or you can take the same alcoholic groups. These on oxidation. So what are the oxidants, children? I have given chromic acid, that is Cr2O7 2 minus H plus. Potassium dichromate in sulfuric acid gives chromic acid, that is H2CrO4. This bit you have learned in the D and F block. In the D and F block, dichromate ion in presence of acid medium converted to chromate ion. Chromate ion is converted to dichromate ion in presence of base. So that was very important bit. The same reagent we are using here, or KMnO4, that is MnO4 minus H plus, this one. Or you can use the CrO3, chromic oxide. So in this case, this will be converted to ketone. This is a ketone. A secondary alcohols on oxidation converted to ketone. And what is happening here? H and H removed here. H2 is removed. That is the only thing. So we need this only, we don't want this one. For example, if I take CH3, CHOH, C2H5. So this on oxidation gives CH3, C double bond O, C2H5, this one. CH3, CO, C2H5. What is the name of this one? 2-butanone. 1, 2, 3, 4, 2 ketone. So that is 2-butanone. Butan 2-1, 2-butanone. So whatever these groups I have taken, there is no change. What happens? CHOH is oxidized to CO group. CHOH, secondary alcoholic group, is converted to carbonyl group. This is the oxidation process. These two are a secondary alcohols. Secondary alcohols. If I take a tertiary alcohol, oxidation of tertiary alcohols. So here children, a tertiary alcohols are not oxidized at normal conditions. Normal conditions. But at high temperatures, tertiary alcohols undergoes oxidation with cleavage of CC bond. This is very important. Till now we have seen the oxidation either primary or secondary. There is no cleavage of bonds. There is no cleavage of bond, CC bond. Only a CHOH is converted to CO. In the first of primary alcohols, CH2OH is converted to CHO. But whereas in the tertiary alcohols, the oxidation is carried out by cleavage of CC bond. So whenever cleavage, bond cleavage is taking place, it needs some drastic conditions. So therefore, tertiary alcohols undergoes oxidation at high temperatures, with the cleavage of bonds. Oxidized at high temperatures with the cleavage of CC bonds. Right children? So this point is very important to remember this reaction. See this CH3, I have taken tertiary butyl alcohol. This is a tertiary alcohol, tertiary butyl alcohol. If it undergoes oxidation, the reagents are same reagents, you can use it. So what I told here, the bond cleavage is taking place. Bond cleavage is taking place. Why? Because in the previous alcohols, when you take the carbon atom which is carrying alcoholic group, that is carbinol carbon, that carbon is carrying at least hydrogen, 1 or 2. In the first primary 2 hydrogens are there, in the secondary 1 hydrogen is there. But whereas tertiary, the carbon that carries OH group does not possess hydrogen atoms. So definitely bond cleavage must be taking place. So whenever bond cleavage is taking place, different options are there. This CC bond, this CC bond, this CC bond are taken. Since all are same, the bond cleavage I have taken here. Whenever bond cleavage is taking place, so I get this part CH3 CO CH3 plus this gives CO2 plus H2O. We have to take 2 H2O. So to balance this one, we need to take 4 oxygen atoms. 4 oxygen atoms. That means what happened here, a tertiary alcohol is oxidized to ketone. This is the first step. Again the ketone is oxidized. So when you take this ketone, CH3 C double bond O CH3, again this is oxidized to CH3 COOH plus CO2 plus H2O. CO2 plus H2O. Right children? Finally, what is the result of oxidation of tertiary alcohol? The result of oxidation of tertiary alcohols gives carboxylic acid with less number of carbon atoms. This is the acid with less number of carbon atoms. So this is very important for objective. Whenever tertiary alcohols undergoes oxidation, we get the carboxylic acids with less number of carbon atoms. You can see in the first step we got ketone and a carboxylic acid. What is this? CO2 plus H2O? No. This is H2CO3, one acid, but this one On